Hey guys, thank you for joining me. Today we're going to be talking about electric current, and I hope that you find this video useful and informative, and hopefully it'll help you understand a little bit more about electric current and clear up any questions that you may have about the topic. Okay, so first off, electric current, let's take a look at a circuit diagram right here. So remember when we're drawing our circuit diagrams, the longer line is a positive symbol and the shorter line is the negative terminal, and then the little squiggly lines to the middle indicate a resistor. So when we're looking at a circuit diagram, our current is defined as the flow of positive particles. So our current is going to flow from positive to negative. This is important to remember and to understand for when setting up electrical currents or electrical circuits in real life, and as well just for understanding problems. So if we think about the flow of current, we're going to remember that that's going to be the opposite of the flow of our electrons, which is an interesting principle if you think about it, that our current is the flow of positive particles. It's going to flow in the opposite direction as our electrons. Current is defined as the amount of charge that passes through the wire over a certain period of time. So we have this equation, I equals Q divided by T. That's going to be an important one to remember. Q, the amount of charge, is going to be in coulombs, and our time is going to be in seconds, which makes our units for current as amperes. So we have 1 ampere is equal to 1 coulomb per second, based on the equation that we have up above. And amperes are abbreviated as A. The other thing that's important to remember, or another fact that will be useful in solving problems here in the future, is knowing that one electron, the amount of charge per one electron is 1.6 times 10 to the negative 19th coulombs. So that's another important thing we need to remember when we're trying to solve problems. If we're trying to figure out how many electrons are passing through a current, or if we know how many electrons, we want to know the amount of charge. These units are going to be important. Cool, so now let's take a look at how electric current relates to Ohm's law. So Ohm's law, if you remember, is the voltage is equal to the current, I, times our resistance. And remember, our resistance is going to be in ohms. So Ohm's law is very helpful because it helps us understand the relation between current, voltage, and resistance. So if we just think about this, if our resistance is constant as our current increases, then our voltage by default also has to increase. Now if we look at a different scenario where our voltage is constant, so staying the same, as our resistance increases, our current is going to decrease. So these relationships are just important to remember and can easily be described using Ohm's law. It's just important to understand that our current and our voltage, they have a similar relationship where they'll both increase, and our resistance and our current have an inverse relationship where as one increases, the other has to decrease. Another unit that we can relate current to is power. So power is another important unit when we're looking at current and looking at circuit diagrams. So power has different units in that it is watts. So it's watts. Watts are joules per second. And we have two equations that specifically relate our current to our power. The first is that the power is equal to the voltage times the amount of current that passes through, or we also have our power is equal to our current squared times the resistance. And both of these equations are just derived from using Ohm's law as well. Okay, so now that we have a basic understanding of current, let's go ahead and jump into some practice problems that should hopefully help you internalize and understand these principles. So in our first problem here, we just have a current of 5 amps that's flowing in a wire for 10 minutes. Remember, amps is our unit for current. It's the amount of charge that passes through time, so Q over T. So we have 10 minutes. So the first part of the problem is we want to know how much charge passes through the circuit. So whenever a problem is asking how much charge, that is the amount of coulombs. Charge is coulombs. So I'm trying to solve for Q here. So if you remember our equation that we talked about, we have our current is equal to Q over T. So we're going to be using this equation. The first thing that we need to do, though, is before we can plug things into our equations, we need to convert our time that's in minutes into seconds. So that's pretty straightforward, right? We just times it by 60 seconds, and that gives us 600 seconds. Once we have that time, then we can just plug everything into our equation. We have the amount of current, which is 5. We have our time in seconds, which is 600, so we're just solving for Q, which is our amount of charge, or coulombs, and that gives us 3,000 coulombs is our charge. Pretty straightforward problem there. Next, so for part B, is we want to know how many actual electrons have passed through the circuit. So if you remember before, or just barely, we solved the problem before. We had 3,000 coulombs that passed through the circuit. If you remember, we talked about the amount of charge that one electron carries is 1.6 times 10 to the negative 19th coulombs. So all we have to do is some dimensional analysis here, multiply that by the number of electrons, and that gives us 1.875 times 10 to the 22nd power electrons. So that is a lot of electrons that are passing through there in a short amount of time. I guess 10 minutes is fairly long. Cool, let's go ahead and take a look at another practice problem, but this time we are dealing with power, practicing using current and those equations that relate current and power. So we have a 12-volt battery power that's connected to a 200 ohm resistor. So we want to know how much current passes through the resistor. So let's see, we have voltage and resistance. What equation uses both voltage, resistance, and current? Remember, that's Ohm's law, V equals IR. So we're just going to do some pretty straightforward math here, right? We have our voltage, plug that in, and our resistor, 200. Solve for the current, that gives us a current of 0.06 amps. So not a lot of current actually passing through the resistor there. Okay, next part is we want to know how much power is dissipated by the resistor. So let's throw these equations up here. So remember, we had two equations that relate power and current. So we have power is equal to current times voltage, and power is equal to current squared times resistance. So we need to look at the wording of the question to determine which equation we're going to use. It says how much power is dissipated by the resistor. So we want to know how much power is passing through or is lost by the resistor. So that means we need to use our equation that actually has resistance in it, which is obviously the second one. If we were to use the first equation, power equals I times V, we would be able to find power, but that wouldn't be the amount of power that's dissipated by the resistor. That would be the amount of power that passes through the entire system, which isn't what the question is asking us. So we just need to make sure that we're using the right power equation based on what the question is asking us. So using that, we're solving for power. We solved for current in the last problem, which we found was 0.06 amps. So that number is going to be squared, and then it's going to be multiplied by our 200 ohms of resistance. And then that gives us 0.72 watts if we multiply that out. So remember, the units for power are watts, which is in joules per second. And I believe that is it for our presentation today. Hopefully you have a better understanding now of current and how current works. Thanks for joining in.